All right, morning. My name is Aaron King. This is a paper, sorry, this is a video about a paper for ECM and aging. Um, let's just share screen here to the paper in question. So this is a paper that I helped work on. I did not do a significant, I did some work on it, but by far, like the heroic amount of effort was put in by Cecilia. So she's the one who did most of this, and then everybody else kind of helped. Colin Ewald is the main professor involved with this. Um, but it's called Strategic Outline of Interventions Targeting Extracellular Matrix for Promoting Healthy Longevity. Essentially, this is a I don't know, roadmap for how do we intervene in the extracellular matrix when it comes to aging. So I'm just going to go over this diagram. And if you want to understand more in depth about any one of these topics, the paper's out there and you can read it. You can request it from various people, including myself. And I will happily talk about it at length with you, but let's just keep this short. Um, so we broke ECM and aging into these different various components. And one of those components is diagnostic tools up here at the top, which then allow us to see what changes are happening, what is going on with the ECM. Those diagnostic tools are used to observe the matrisome. So the components of the matrisome are in blue here: collagen, ECM glycoproteins, proteoglycans, the molecular building blocks of what your ECM is. Um, those get affected by these yellow I wouldn't say that they're pathologies, I would say that they're conditions. So this is what happens to the ECM as it ages. There's a loss of proteolysis. Advanced glycation end products accumulate. There's inflammation. There's UV damage, ultraviolet damage. There's calcification and mineralization that occur. These yellow conditions then lead to these orange and red pathologies. William Behrens syndrome, cancer, cell death, heart failure, kidney failure, all these things that occur and destroy the human body as a result of the ECM degrading over time. So the question is, what can we do to intervene with these things? And the answer are well, some ideas that have come up are these teal sections here, which is the idea, like small molecules for ECM homeostasis, controlling ECM turnover, glycation cross-linking breakers, controlling downstream signaling, and producing young ECM. So these are ideas of how to mitigate or slow down the various conditions that lead to pathologies that are a result of ECM destruction. Um, so that's the thing in a nutshell. What I'm most concerned with, and I would like to draw attention to when it comes to this paper anyway, and also to the whole field, is diagnostic tools. The diagnostic tools right now, there's a lot of them, but most of them they're too advanced, I guess, or complicated. They're not accessible to the average person. So if I want to measure the state of my ECM, I don't have a lot of options. If you had access to blood draws and urine tests and mass spectrometers and a high pressure liquid chromatography and all sorts of other things, you could probably do a lot, but it'd be expensive and it'd be slow. What we need are more tools like this thing, um, where it just shoots a laser beam at you and it measures your skin, and it has some kind of a reading that's related to ECM. Unfortunately, this tool here, the one I just showed you, is not quite sufficient for practical use right now because it has a confounding factor in which it's measuring both supposedly advanced glycation end products in the skin, but it's also measuring skin hydration because of the way that it works. It uses ultraviolet light, which gets absorbed by water. So the more hydrated your skin is, the better your number comes out to be. And skin hydration actually changes with age. So it's not it's not quite an accurate tool in terms of measuring. We don't know exactly what it's measuring, I think. I think that it's very useful still because it's measuring stuff with age, but not to belabor the point, we need better diagnostic tools that can produce massive amounts of data very quickly so that we can see natural variation and also see trends over time with the ECM. And also, if we were to do interventions with ECM, you need to be able to show people what's changing, and there's not a good way to do that right now. So that's what I want to harp on a little bit. This is a very excellent, I guess, overview and organization of all the different pieces of the field of ECM and aging. Let me just zoom out a little bit. And I would encourage everybody to read this paper if you're interested in ECM as it's related to aging. And I'll leave you with this top level view, I guess, which is why is the ECM so important for aging? Because it is the case that for in like cellular functions, nature's actually already solved the problems of the cell. In germline cells and also in all single-celled organisms around the world, they can exist indefinitely. And the issue then becomes that those things, those germline cells, haven't quite figured out how to solve the structure that surrounds them because they've never needed to. So whilst nature has figured out how to make the cell exist indefinitely, it hasn't figured out how to make the material around the cell, the extracellular matrix, in whatever shape that it takes, exist indefinitely. And so that becomes a problem for us because we are actually mostly ECM. Most of our body is ECM material. The most abundant protein in your body is collagen, and it's by far the largest in terms of volume problem that we face when it comes to health. And so, yeah, I agree. I encourage you guys to read the paper. It explains a lot. Diagnostic tools are important, and hopefully we continue to see progress in this front. And it's very interesting, and I appreciate being a part of this effort here. So thanks to everybody involved. All right, take care.